I'm Angelo Caltan, and today I will present three problems from Chapter 14 of Physics. Problem 14.8. In a physics lab, you attach a 0.2 kilogram air trap glider to the end of an ideal spring of negligible mass, and it starts oscillating. The elapsed time from when the glider first moves through the equilibrium point to the second time it moves through that point is 2.6 seconds. Find the spring's force constant. So the formula we start with for this problem is period equals 2 pi times square root of mass over spring's force constant. And then we isolate the spring's force constant, which will give us square root of spring's force constant equals 2 pi times square root of mass over period. The, Plugging in the values, this will give us 0.5404. And then we have to square it in order to get K, or the spring's force constant, 0.292. Problem 14.9. When a body of unknown mass is attached to an ideal spring with force constant 128 newtons per meter, it is found to vibrate with a frequency of 6.2 Hz. Find A, the period of the motion, B, angular frequency, and C, the mass of the body. So, period is just the reciprocal of frequency. So 1 over F will give us 0.161 seconds per vibration. Next, angular frequency equals 2 pi times F. This will give us 38.9557. Next, the mass of the body can be derived from the formula we used in the first problem. Isolating the mass of the body, square root of mass of the body equals period times square root of the spring force constant over 2 pi. This will give us 0.2899. Square that, this will give us that the mass of the body is 0.084 kilograms. Problem 14.26. A small block is attached to an ideal spring and is moving in SHM on a horizontal, frictionless surface. The amplitude of the motion is 0.2 meters and the period is 3.45 seconds. What are the speed and acceleration of the block when x equals 0.160 meters? So first we get the angular frequency, which is equals 2 pi times f. This will give us 1.8212, and then we plug that into the formula for speed or velocity, which is velocity equals angular frequency times square root of amplitude minus displacement, amplitude squared minus displacement squared. This will give us 0.2185 meters per second as the velocity. And then to get the acceleration, we will use the formula acceleration equals negative spring force constant times displacement over mass. Since k over m is just angular frequency squared, we plug that in. So it becomes negative angular frequency squared times x. This will give us negative 0.53068 meters per second squared as the acceleration. So thank you for listening, and I hope you learned something from my explanations.